All right, one more week, and we have. I don't know. This is going to be a fun week. We're going to try and figure this out as best we can. But chapter 9, as normal, let's dive in. So this week we have. We're going to be dealing with file systems. So we're going to talk a little bit about where things are, how things are put together, why you want to go in specific directories, where stuff is stored, all of that kind of fun stuff. We'll do that for both Windows and Linux, and then I will show y'all a little bit about how it works in practice. I don't want to. I'm on a Mac today, as you can probably see. I don't want to stress it out too terribly much. I've had a couple of application crashes, so let's take it easy. Anyway, so file systems in Windows. As you probably know, you're on a Windows machine, so you probably have seen this. If not, you will be seeing a lot of it here pretty quickly. So the C drive, this is your main partition. When you install Windows, this is where all of your junk ends up getting thrown. Unless you have done some kind of crazy configuration at the very beginning, this is it. So the C drive contains a lot of this stuff. Contains program files, and oddly enough, program files x86. So these two directories contain all of your applications. This is where, when you install Packet Tracer, when you install Chrome, when you install Firefox, when you install VirtualBox, all of that kind of fun stuff, this is where those things tend to go. If you have older legacy applications, and you'll hear legacy a bunch, legacy just means old. If you have a bunch of those types of applications, legacy applications, they will typically get stored in x86. But there's one thing that differentiates what goes into program files and what goes into program files x86. Or at least that's what Microsoft wants you to know. x86 is for 32-bit only software. So really, really old stuff. For program files, this is 64-bit applications. This is where all the new stuff goes. Pretty much anything that you install now will probably go into program files. It is pretty rare anymore to see anything go into program files x86. But that's it, right? All your applications, that's where they go. Yeah, I guess I might as well show you because I'm on a Mac. On Mac, they're just here in Finder on applications. Hang on. There we go. All right, so program data. So program data is a directory in Windows that contains all of the information about programs in program files, but stored separately, right? This is so that you can uninstall applications from program files, and your configuration for those applications will be stored. So, right, like you install Microsoft Word, it lives in program files, all of the configuration actually lives in program data, so that when new updates come, it basically uninstalls the old stuff, reinstalls the new stuff, all of your configuration, right? Like where you left a window, your Microsoft Word preferences, like your favorite fonts and things like that. Those are going to stay because they live here instead of in here. Now, you may run into the situation where applications store per user data, right? So remember that program data is going to contain global configuration, right? This is configuration that will affect every single user on the system. So if you've got multi-user systems, which are becoming less and less common, but if you have 5 different people that log onto a machine and you want the configuration of your say Microsoft Word to be the same across all of the users, that's where this is going to be stored in program data. If you have per user configuration, right? Like you want the 2 different users to have 2 different preferred fonts or something like that, those configurations will be stored in app data. So app data lives in C users, the name of your user, so in my case it would be C users Leo, and then there's a directory in here called app data. where my specific user's configuration will be stored. So that leads me directly into C users. So this is just basically the home directory for any given user. If you're storing or if you're downloading stuff, it's under C users, Leo downloads. If you're storing documents, that's in documents. If you have music, that's under music here. The idea is that every time that you store something that pertains to your particular user, it gets stored under C users. This is probably one of the very few directories on the entire system that your user account actually owns. And we'll talk about file permissions here in just a minute. But that really just means that your user has full control of the directory inside of here, or at least directories inside of your user directory. So anything under this, C users Leo, all of those are my directories. I can delete them, I can add stuff to them, I can remove things from them, all that fun stuff. So C users. And there is a user directory for every user that exists on the system. Now C Windows. This is a directory in the file system that stores all of the Windows type applications. It's going to contain like your bootloader. It's going to contain all of the files that need to be loaded up to actually boot Windows, and pretty much anything related to the system. This is where all of that goes. When you update Windows, when you're going through, say, the updater, you let Windows Update go and do its thing. It downloads updates. It takes forever to install them. You reboot. All of the things that are happening during the Windows Update procedure is happening in this directory. Now, if you have additional stuff in, like Windows or Microsoft Office updates or whatever, now that'll obviously happen here because that's where Microsoft Office is stored. But if it pertains to Windows itself, when you're doing a feature update specifically, this is going to happen right here in the Windows directory. So the registry, this is all of the configuration that happens throughout the system. So if you need to remember that a particular program has a serial key. So one of the things that you tend to do on a lot of software that is installed in Windows is provide a key when you install it to prove that you've paid for it, or to store any kind of authentication, things like that. That is all stored in the registry. So a lot of times in the registry, well, pretty much every time in the registry, you are going to be looking at a situation where stuff is stored in octal or binary or even hexadecimal. So this is not really a place that you as a user or even an administrator will go to make a lot of changes. You can make changes here, but a lot of times the registry really just points to things in program data or app data, or program files. So there's usually a graphical user interface application, something that you can click on, check a box, click OK or whatever, to directly configure the registry. Now, there are things in the registry that you can do that do not have a graphical counterpart to. That is really the only time that you'll ever really deal with the registry. So we're going to go in and look at these things again here in just a second. But again, I just wanted to make sure that yeah, this recording goes swimmingly. So we'll come back to those here in just a minute. So anyway, file permissions in Windows. So when you right-click on a file, hit Properties, or right-click on a directory and hit Properties, this is a file, pia.txt, you're going to see the types of permissions that any given user or group has. Now, if you take a look, you see two people here. That represents a group. So the authenticated users group, the system group, the administrators group, the users group. Now, if you ever see a single person on the icon there, that is a single user. Windows does not really enjoy setting up single users as owners or as, I guess, additions to permissions or properties here, the security properties. You don't really see that a whole heck of a lot. but you certainly can. If you click Edit here, you're able to add and remove users and groups, and you'll be able to change the different permissions as long as you have permission to do that, which requires full control. If you're changing permissions on a file or a directory, you have full control of that resource, whether that be a file or a directory. So modify. You're pretty much able to do everything except change permission. Right, so if I were to go in here, click on Edit, select Users, check Modify, anybody in the Users group, which is pretty much everybody that you create on the system is automatically a part of the Users group. So this would effectively give everybody, if I were to go in to check that box, effectively give everybody the ability to delete this file. Now if I did that to a directory, you would be able to delete the directory and all of the files inside of it, or any given file inside of it. This is an idea called inheritance. This is pretty unique to Windows. This does not extend to Mac, nor does it extend to Linux. Inheritance is pretty squarely a Windows thing. So if you were to go in and say this was a directory named PIA instead, we gave users modify to this directory, they would be able to delete that directory. Now that idea extends to Linux and Mac, but the part of inheritance that does not extend to Linux and Mac is that if you were to create a file in that directory, that file will automatically inherit the ownership, that users and modify permission. Any file created in that directory will inherit that. So users then would be able to deal with files inside of that directory as well. That is inheritance. So in Linux or in Mac, if you create a new file in that directory, the person or the so say users here, they do not automatically get those same permissions on any file that you create inside. So we'll go through some examples of that. I know that's just talking, so hang tight. We'll actually go to that. Anyway. So here's a quick explanation of all of the different things that you can do, or all of the different full control, modify, read, write, the things that we saw right here. A quick explanation of each. You can do anything. Can't deal everything that full control can do, but without permissions. Ability to read, ability to change a file, but cannot delete. Read and execute, so you can do read and run it. So if it's a .exe file, you can actually run it. List folder contents. If you don't want people to be able to see what's inside your directory, you want to remove this permission from everybody else. And then special permissions. So they're actually more granular than this right here. And we'll take a look at those here in just a minute once we get done with this last little bit. So in Windows, we tend to be able to add new disks. And that tends to come in the form of just plugging stuff in, right? I mean, a USB disk or something like that. But a lot of times, we add a physical SATA secondary disk, right? Like we open up our computer, we pop in a new disk, we reboot or we turn on the machine after the operation, and then Windows is like, hey, I've detected a new disk. What do you want me to do with it? And we'll go through the process of actually putting a partition table on it, then formatting it with a new file system, and actually mounting it somewhere. So mounting in Windows is actually pretty easy as far as everything goes. You just assign it a drive letter and Windows takes care of it from there. Mounting in Linux is a little more involved, but for now, let's take a look at Windows. So let's fire up Windows 10 and I will show you some examples of all of this stuff that I've been talking about so far. Again, I'm doing it this way, so just in case OBS decides to crash, I'll be able to stitch these videos together and still give you guys one coherent video. So bear with, I know it's a little out of order. I try to show and tell at the same time, but not today. Whew, this is not the fastest thing in the world. All right, so let's take a quick look what I was talking about before. So the C drive, obviously where all your Windows stuff goes. Inside of C, you can find program files, where most modern software is stored. Program files x86, where legacy software is stored. You do not see program data. We'll come back to that in just a sec. You see users. This is obviously where the Leo directory is, and inside of that, you'll find my desktop, documents, downloads, all of that kind of fun stuff. This is where Leo lives. Windows, where all of the system software lives. And now let's go take a look, right? Under View, you can show hidden files, and that will expose program data to you. Now, it's hidden for a reason, right? This is not user configurable stuff. You don't typically do that. But you can come in here and make some changes or delete some stuff. A lot of times, if software is misbehaving, you can come in here and delete the things that delete the configuration files pertaining to the software that is misbehaving. Restart that software, and all of this program data will need to be recreated. And a lot of times, what will happen is it'll just recreate stuff from scratch, and it'll forget all of its previous settings. Now, this also pertains to app data. Notice when I went into users, app data did not exist, but now it does. So same here, right? If you view hidden files, app data will show up, and most of the stuff shows up in roaming. So delete the application in roaming, and it will typically reset. Some applications need to be deleted from both app data and program data if it stores things in both. All right, and the registry, to get to it, type in registry, you'll find the registry editor. Yes, we want this. A lot of times you're going to find pretty much everything inside of HQ local machine, HQ users, and HQ current config. So HQ local machine is going to have information about, right, very basic stuff, a lot of the basic Microsoft stuff, like the media player. You can see where it is installed to, or where Windows expects it to be installed to. Right? And these are not necessarily things that are supposed to be user configurable. Windows exposes this to you for power users, right? If you know what you're doing, you can come in here and make some system changes if you'd like. However, not recommended. If you make changes that are not compatible with your current system, you can break your system. So this is not really something that you want to come in and actually make changes to. So basically, if you go into the TechNet forums and you get a Microsoft response and they say, go change this in the registry, cool, go change that in the registry. So unless you know what you're doing, stay out of the registry. All right, so about these file permissions. So we can come in here, come back to users, Leo, let's look at, I don't really have anything in here, but we'll look at this. Properties, and under security. So you can see here, it's in my user folder, right? So I have full control of it. Which also means that I should be able to come in here and add other people to it. So let's see, we'll just add the entire users group, and we'll give them read. Read and execute. So they'd be able to double click on this thing and run it from my directory if they so choose. And then you can verify the permissions at the end of this right here. It's that easy, right? Come back in here if you decide that that's not what you want them to have more, you can come in and add them all the way up to modify. Sure, let's do that, right? And then you can go verify those again here. No big deal. They're missing full control, but they have pretty much everything else. If you'd like to see the special permissions, again, this is not really something that you're going to be dealing with a whole heck of a lot. You can come in and actually do that. So you'll first start off with selecting a principal, which is the user itself. And you want to allow them, come over here to advanced. And these are the special permissions that you can allow outside of the typical full control, modify, read, write, all that kind of fun stuff, right? So if you need to get more granular with it, you can do this and set up special permissions. Now, when you come in and take a look on this window, all you're going to see is special permissions checked. If you have any of these major permissions checked, those will also be checked. But if the only thing that you have is special permissions checked, you'll only see this checkbox checked. So it's pretty easy to come through and verify who has what permissions, right? That's it. This applies to directories as well. And so remember, I was talking about inheritance. If you were to add the users group here, give them modify, any file that you create, notice this is the desktop, any file that you create on the desktop will also gain those same permissions that you've given users to this directory, to the desktop. So if you create something on the desktop, users will be able to, let's say we added the modify, users will be able to modify those files as well. That is a Windows idea of inheritance. The reason I harp on inheritance so much is because when you start dealing with additional disks, when you start dealing with file shares, you have to be very careful with what types of permissions you are giving to the C drive. Because the users directory exists in the C drive. So that means that any permissions that live in the C drive are inherited all the way down unless explicitly said otherwise. So notice, users can read pretty much everything, but they can't do anything to anything else. Now the users folder has special permissions. It has inheritance blocked from above. So the permissions of C do not flow down to users, but the permissions of users does flow down to everything else. So this is just a bit of, you're going to have to know how Windows deals with these things. Now, this is not going to be on any of the tests that we're going to be dealing with or anything like that. This is just something that you're going to need to know, especially when you start getting into the server side of these things and dealing with file shares. Now, we're going to deal with file shares a little bit later on in the class, and this will come up again. So, yeah, we will cover this at least briefly again. So, the last thing that we were talking about is mounting in Windows. So before we do anything with mounting, we're going to need to add a drive. So in Windows, you're going to deal with the same thing. Nothing is I keep doing that. It's this one. Oh, wait. All right. So in any VM, you'll open up the settings of that VM, go to storage, under controller SATA, click the plus on the right hand. There's two icons here. Click the plus on the right one. That is adding a hard disk, so you'll want to add one. Oh, we'll need to create one. There we go. Click on continue, continue. I don't need it to be that big. Let's go with 5 gigs. That should be good enough. Not attached yet, but when we click choose, it will attach it to this machine. So notice we already had our Windows 10 VDI prior. That was 50 gigs. Now we have our Windows 10_1, our second one. Now the naming, you can name it whatever you want to. It doesn't matter. You can do that during that whole process. I don't particularly care what you name them, so that's fine. You can see it's 5 gigs, only 2 megs so far. It'll grow as we start putting stuff into it. But notice, right? 2 drives. That's the big thing that you need to pay attention to when you're dealing with this. Make sure you've got 2 drives in there. And start this bad boy up. All right. So far, so good. Nothing has crashed yet. feel like I'm getting overconfident though. All right. So, unlike USB drives, Windows does not just throw it out into your face and say, hey man, by the way, you attached a disk. You physically did it, so it just kind of assumes that you know what you're doing. So what you'll want to really do in situations like this a lot of times is right-click on Start, go to Disk Management, and then you will be provided with the options to, there it is, add the new disk. So if you look behind, before I initialize this thing, you can see that it's unallocated space. There's a little red arrow down, meaning the disk is not being touched at this moment. You get these two ideas of MBR and GPT. Typically, most systems will use GPT from here on out, but you get to choose when you add new disks. The idea with this is that MBR is the older style partition table, and the big limitation of that was that you could only have up to 2 terabyte partitions. So if you had really big disks like the 4, 8, 10, 12, 16 terabyte disks that we have now, you cannot use MBR. It will not be able to extend past 32-bit, I think it's 32-bit, what FAT32 was able to deal with. So 32-bit sizes, which effectively keep you from using anything larger than about a 3 terabyte disk. But with partitioning and everything else, you're really dealing with smaller than 4 terabytes overall. So GPT is the answer to that. GPT can deal with multiple hundred of terabytes, if I'm not mistaken. So we're not quite to the point where GPT has hit a ceiling just yet. So it doesn't really matter what you choose for the size of disk that we have. However, if you're dealing with larger disks or if you're trying to be forward-thinking, you can just use GPT every single time without having to think about it. Legacy applications sometimes require MBR, but you'll know that going into it. You won't really just get surprised by, hey, surprise, MBR. It doesn't really work that way. So anyway, you initialize the disk, you put a partition table on it, and then you can right-click into this situation here. This is the entire disk. You can right-click on it. At least for our purposes, new simple volume is probably going to be good. Next on through. It's going to give you, by default, it's going to give you the entire disk in this little window. So if you just click next, it's going to use the whole thing. And then it's going to ask you what drive letter do you want. You can choose anything. It's not going to be detrimental to the system to choose any drive letter, assuming that drive letter is not used anywhere else. So as long as T, in my case, is not used for any other thing, this will be just fine. We can name this thing. We'll name it extra. File system, you typically don't want to mess with this as long as you want your the permissions that we are able to deal with. NTFS really allowed us to have those granular permissions that we were looking at before. That is a product of NTFS, so the new technology file system. Pretty much what every Windows installation lives on is NTFS. FAT32 is for older, smaller drives. It typically does not get used for pretty much anything anymore. Leave allocation unit size as default, and perform a quick format. That's always a good idea. It really just destroys the partition table and rewrites it whenever you create a new one. So click next, and that's it. This will give you a reminder of, hey, this is all the stuff that you chose. Hit finish, and you're good. So now you can see you can click on this, or you can right-click here and open it. And now you can see you can start creating files in it, all that kind of fun stuff. New folder, create a file. Sure, bitmap image. We can, let's see, we can edit this if we want. Yay. All right, save that bad boy. Cool, so our secondary disk is doing what we want it to do, which is, obviously, store files. Now, the whole reason that we're going into this is that I'm in the T drive now, just in the root of T, Here, let me show you. Go to this PC, go into T, and anywhere in the white space you can hit properties, and you can see the permissions that have been given to this thing right off the bat. So users have read, list, and write. My user, though, my Leo, is an administrator, so I inherit these permissions here. So any other user will be able to read stuff off this disk, but nothing else. Now, here's what I'm talking about with inheritance. So we go in and we look at this bitmap image, and you can see those same permissions exist here. Right? Because bitmaps are not executable files, you don't tend to get much more than just read or read and execute, stuff like that. But that's pretty much it. Any file that you create inside this folder is going to have those same permissions. They will always flow down, and they start at the top of any mount point. And in Windows' case, we're talking drive letters. So be aware. If you want nobody outside of the people that you say, you can come in here and say something like, just remove users. Hit OK on that, right? Now only administrators and authenticated users. So this is another thing that you're going to have to watch out for. Authenticated users is a special group that means anybody that logs into the system. So this also includes regular users. So you'll probably want to get rid of that as well. So we're just looking at how do we make this disk as secure as we possibly can as far as permissions go. Now, this does not cover if someone were to like steal the drive out of the computer and take it somewhere and plug it into another computer. They can defeat permissions that way. So permissions are not the end-all be-all of security. But keep in mind, this is how you control it. Beware of inheritance. Everything always flows down. All right, that's it for the Windows side. Let's start talking about the Linux side. I'm going to bring up the Linux VM now. See if that works. So I'm going to make a lot of comparisons here, just simply because there are a lot of concepts that exist in Windows that also exist in Linux, but they are dealt with differently. Mounting is one of those, where the idea is the same, but like Linux doesn't do drive letters, so we'll talk about a lot of that. All right, so where you had C drive in Windows, Linux has this. That / is called root. It is the root or the top of the file system. Everything goes in root. Now in Windows, everything goes in C that deals with the system for the most part, and any other additional disk gets its own drive letter and new trees are spawned, right? So there are things inside of C, there are things inside of D, E, F, G, depending on how many disks you have, obviously. In Linux, everything is in here. Everything. You cannot put something in a Linux file system that is not underneath here somewhere. So instead of C, D, E, and F, things go into media or under M and T. Now, you can put stuff anywhere. You can mount entire drives anywhere you want. But where it won't be is under a drive letter. So Linux is different in that way. So we'll talk about what some of these directories mean. I'm going to go over these pretty quickly. I'm not going to test you on a lot of this. So to be honest with you, this is just stuff that you're going to run into in the Linux class. This is more of a primer. So bin, common program shared by the system. Bin and There's also a bin inside of this directory, so USR bin. Let me see, I can show you that. A lot of this stuff is hard to visualize, so this is why I wanted to have a Linux machine going at the same time. So we can go into bin, and you can see system control is like the essentially the software that runs the entire system. So that is what bin contains. Pretty much everything that is required by system. So this is the equivalent of, say, C Windows. Boot contains pretty much all of the stuff that is required to boot. Now, in Windows, this is also under C Windows. There is a C Windows boot, if I'm not mistaken, and then there's a boot MGR directory inside of there that will contain similar stuff to boot. So boot contains the grub, which is the Grand Unified Bootloader, essentially the thing that talks to the BIOS. When the BIOS hands off control to the operating system, grub is what grabs it and says, hey, the operating system's over here. And then the operating system starts to load. Boot also contains the kernel, which is the heart of the Linux system. Dev. Now, Windows doesn't have an equivalent to this. Dev is where all the devices go. You plug in a mouse, it's inside of here. You plug in a drive, you plug in anything. Any device, hardware or software, lives in dev. Etsy, we were talking about program data. That's pretty much what Etsy is. So it contains all of the configuration for any software that you have on the system. So etc. Now, here's the deal. Here is that same listing, right? Bin, boot, dev. We don't have CD-ROM. CD-ROM is obviously what it says it is. It's the CD-ROM. etc, home, lib, lib64, right? So a lot of these things exist. And if we do pwd, so that just shows you the current working directory, it's that /. Inside of that is bin. So if we do cd bin, you can do pwd, and you can see /bin. The idea with that is that these directories are no differently, they don't work any differently than they do in Windows. Everything sits inside one way or the other. And you can see this graphically as well. So notice up here, we're in root, and you can go to bin. And inside of bin, you have a bunch of software. Bin is short for binary. So you can see it graphically, you're in the terminal, but typically in Linux, you're in the terminal. And Etsy's in here too. Contain lots and lots of directories. And if you look, these are the softwares that are available to you in Linux. I don't have a lot installed on here, so obviously, but you'll find things like Firefox in here. Everything else. So again, as with Windows, if software is misbehaving in Linux, you will want to delete the directory for Firefox if Firefox is what's misbehaving. And like in app data, the user directory or the home directory has similar information. So if we go to home, which is next on the list, this is the same as the user directory in Windows. Go into Leo, you find the same kinds of stuff. You show hidden folders and stuff. There it is. And you'll tend to find dot directories. So this is the equivalent of app data, these dot directories. All these control different things on the system. So once I launch Firefox, there'll probably be a Firefox directory in here, something like that. If not here, then maybe under cache. But the idea is these dot directories are similar to app data in Windows, and etc is similar to program data in Windows. So you only find this on some distributions, but this is the initialization's information. Systemd is taken over, so you don't find this on most modern Linuxes. Lib. And you'll find lib64 as well for the same reason that you found program files and program files x86. on Windows. So lib are the 32-bit directories. Lib64 are the 64-bit directory, or I kept saying directories, libraries. So libraries is basically just shared code. So Linux tries to be as, here they are, lib and lib64. Linux tries to be as efficient as possible. So if there is any shared code, so say you have Firefox and Iceweasel, which is another browser, they would probably share a lot of code because they come from the same code base. That code would live in lib64, and Firefox and Iceweasel would both pull from there, therefore saving you some disk space. However, Linux is starting to move away from that paradigm just simply because space is cheap now. Lost and found, you find this on every single partition. The idea with this is that if something has gone wrong with file copies, you'll find it in lost and found. So pretty much just broken stuff goes in there. You find this on some Linuxes. I don't think we have it in here. Yeah, so the Ubuntus don't have miscellaneous, but quite literally it's for miscellaneous stuff. There's no real reason, or no real definition for what goes in here. MNT and media. Depends on the distribution that you're dealing with, that you have either of these. But they're basically the same exact thing. So in Linux, you tend to have media. I actually have both. Nothing in MNT and nothing in media. If you plug in a flash drive, Ubuntu tends to mount it under media. So in Windows, you plug in a flash drive and you get F. In Linux, you plug in a flash drive and you get the name of the flash drive loads up right here. And that goes with pretty much any other disk that you put in here as well. Yeah, so instead of getting a drive letter, it just mounts somewhere on the file system, and media tends to be where that somewhere is. You can control that. Again, you can put it anywhere you want. You can put it in net, you can put it in opt, you can put it in root, you can put it in temp. It doesn't matter where you put it. The idea, though, is that by default, Linux will probably put it here. You won't find net everywhere, but a lot of times this was like network shares. You would mount them here. Ubuntu does not have that directory. But you can create it, right? There's nothing saying that you can't create these directories inside of here either. Opt tends to find optional software. For the longest time, Packet Tracer lives in opt. I don't know if it still lives there. I don't think it does. I think it's standard now, so it ended up in like user bin or something. But opt tended to be where Packet Tracer or any other third-party software got installed. So opt was kind of like program files. Proc. Now, this is not really a directory. You don't really go put stuff in proc. You can, but it's not recommended. Proc contains information about the actual processor, as well as memory, as well as cache. So these are really just an extension of the saying that everything in Linux is a file. Yeah, they're serious. The processor itself is a file. Every process that you run is a file as well. So if you go into proc, you see these numbers, right? Right? All of these numbers. These numbers are actually processes. So we don't need to really get into this too terribly far, but you can find every single process on the system, right? See a process ID of 1895. And I betcha you can go down here and find 1895. So if I deleted this process would stop. It's probably a bad process to stop. User lib mate panel notifications area applet. That's this thing right here, right? I wouldn't know what my battery life looked like. I wouldn't know what my clock looked like. I wouldn't know that I needed updates, right? So killing that process is probably not a good idea. But the idea is the same, right? So a process is not actually a file. But in Linux, it kind of is. Right? Everything is written to disk somehow, or at least written to memory so that it can be moved around and stopped and started and all that kind of fun stuff. So just remember that proc, yeah, it is a directory and it does have files inside of it, but they're not typical files like we would create, like text files or something like that, right? These are links, essentially, to hardware and software that exists on the system. So root. Root is a directory that is owned by the user root. All right, so there's a distinction. This is the root of the file system. This is the user root's home directory. Yeah, they could have chosen better terminology for this, but it is what it is. So there is a root user. You can with the correct configuration log in as root. But that is totally separate from the root of the file system. That is the terminology, so I'll be using it that way. So be aware. Root's home directory looks like this. Root of the file system looks like this. And if I were root, well, I can do it even not as root, but notice a little X right there. I don't have permission to go in here and see this stuff, right? I am not root. Root is special. So, oh no, I think I broke the, oh, there it goes. We're good. Come back. All right. SBIN. So more common software more likely that a admin or a user might use. Rest of the stuff lives in USR, Unix System Resources, not user. I will pronounce it as user because it's easier, but it's USR, Unix System Resources. So inside of USR, you'll find, yeah, this is your more common software. User bin, so for Unix System Resources, so user binaries. And this is where it gets kind of silly, where I will pronounce it user bin. And in this case, it can mean user, because you tend to find user software here. But know that it is Unix System Resources. So user bin, user sbin, this is where all your software is. TMP, this is temporary stuff. Pretty much every Linux has a TMP. And just temporary stuff goes in here, right? Stuff that will not be kept for a very long time. TMP does get deleted from time to time, whether that be at a reboot or every couple hours or whatever. We can go in and check cron for when that's going to happen next. Cron is a way to schedule things. But for now, we'll just focus on the fact that TMP is temporary. Don't put anything in TMP that you don't want to lose. And then var. var is pretty much anything that is variable. So something like logs. Logs change all the time, right? Every time you do anything on Linux, there's a log of it. And so that file that contains those logs change. And so those logs, if you go into var log, exist here. Right, and a lot of times you'll see auth log, so anything that had to do with authentication, so I logged in at 11:48. Well, most likely anyway. The last time this file was touched was at 11:48. So I would imagine that's when I logged in. And same with boot, right? 11:48. We can read these things. I'm going to use sudo var auth.log. Oh, var log auth log. I can't spell. There we go. And then, yeah, you can see, right? Oh, yeah, take a look at that. This it will have just changed. Because I used sudo. So I did a super user command. And it got logged. So this thing actually changed at 12:04. So if we do an LSL again, take a look. It updated. 12:04. But I didn't reboot, so that didn't change. Obviously. Anyway, so var contains pretty much everything that changes a lot. And you'll find mail here as well, right? Mail changes all the time. Every time you send a message or receive a message, mail will change. Now, there's internal mail on a Linux system, like two different users can mail each other back and forth. That is a thing. Doesn't get used a whole lot, though. And spool. Anytime you print something, goes here. Var spool. So again, and yeah, backups, right? Backups can change all the time because anytime you make a change to the thing that you want to back up, it changes. Anyway, there's more to it than that, but that's the idea. That's the basic idea of pretty much the entire file system of Linux. Ooh, this is kind of out of order. Let me move this to the bottom. Let's talk about permissions for a minute. Now, I do not expect you guys to fully understand permissions by the end of this, and I do expect you guys to ask for help. Permissions in Linux are a little more in-depth. They're more simple overall, but because of the way that you have to deal with them, they're a little more in-depth, so you have to think about them a little bit more. So let's start. This is a screenshot of permissions on a few directories and a couple of files. So looking at this, how we get them, right? I've been doing it this entire time. You guys may not have noticed it, but you get these same lines. So if you look, very first letter, there's a D, there's an L here, there's an L there. If you go in, let's go into log, we can see here that there's a dash there. If we go into, let's see, dev, you can see B here. Let's see, let's do TTY. You can see C here. So there's a few different things, right? And so the D stands for directory. The C stands for character, which means these things will accept characters. TTY is actually what I'm on right now. I'm on a pseudo terminal. These are terminals. Don't worry too much about the terminology. I'm not going to test you on it. We saw L for link, so like a shortcut. We saw B for block device, so anything that can store stuff, anything like an SD card, flash drive, hard drive, any of that. So you have your different designations for different types of files. This very first thing, right? The most that you're going to see is typically, though, D and dash. Dash just means regular file. It could be just about anything, to be honest. It could be a PDF. It could be a tar gzipped directory. So think of that as like a zip file. A zip file itself. You can find MP3s, all of that kind of stuff, right? Those are just files. And then directories. And then to the right, you'll see a few other things. Let's go in here and look at these things. So you see these. These are actually the permissions on this file, or directory in this case, right? So there's a D here. So we're looking at a directory. Here are the permissions. So RWX, R-X, R-X. It looks like Greek, but it's not. It is actually fairly simple. The hardest part is remembering what each thing stands for and how to get there. So RWX. There are really actually three sets of permissions here. So RWX references this guy. The second set of three references this group. And then this last set of three represents everybody else. So notice, here's the, so this first RW dash is this guy. So root has read and write to this thing. This second set references here. So the dial-out group has read-write access to this thing. And then everybody else has nothing. So in Linux, you have users that show up in this left-hand column here, and groups that show up in the right-hand column here. If you ever see the same user and group, that means that we want this file to be touched by as few as people as possible, right? This is my home folder, so I fully own everything inside of it. Now, once you get outside of the home folder, though, things change. Go into var log again, right? So root. Nobody but the super user of this machine should be able to look at and deal with anything inside of this. However, we've given the others read. So little old me can actually read this file. Now this is a better example of what I'm getting at. So the syslog user can read and write to the auth.log file. The ADM group can read. Everybody else can do nothing. So I'm not actually able to. So if I just, cat means to read the file. Oh, I've already sudoed it, so that's going to actually, oh wait, no, hold on. Oh, I'm in the ADM group. Yeah, that's why. So I'm in the ADM group, so I'm able to actually read that. So if I created another user that wasn't in the ADM group, I would not have been able to do that. So that made all the difference. I am in that group, therefore I can read. If I were anybody else, I would not be able to do anything. Now, in this case, let's look at this one. I should be prevented from doing this. So root can read and write, references this. The root group can do nothing. So boot.log should be, I should be prevented from doing that. There we go, permission denied, right? I'm not in the root group, therefore I cannot look at any of that. All right, so that's how those permissions work, right? In this case, the user that owns it has read, write, and execute, meaning I can run this. So a directory has to have execute if you want to actually go in and out of it. So if you want to be able to double click on it and get into that directory, or do a CD like I was doing here in the terminal and get into it, it needs to have execute. Kind of weird for a directory, but it is what it is. The group has read and execute, so the root group can get in and out of it, and everybody else can too. This is the other group. All right, so how do we get there? Let's look at a given file. Let's go back home. Now you can do this stuff in the graphical mode. However, it's a little weird to do so. Most anything that you ever see as far as Linux is concerned is you're gonna see it done on the command line. So just as a quick aside, you can do it just like in Windows. You can right-click on it, hit Properties, go to Permissions, and start messing with it, right? So folder access, right? You can list, you can access, you can create and delete files, blah, blah, blah. Group can do similar things. You can assign the group. And then what do you want others to be able to do? And do you want it to be executable or not? So with a file, very similar, except fewer options, right? And allow executing if you want. But you'll typically do it in the command line, which is where all this junk on the left-hand side comes up. So let's look. Oh, let's go into, where did I create all that stuff? Documents? No, where did I create it? Oh, downloads. All right. So I'll go back one and go into downloads. There we go. All right. So let's take a look. It's a regular file. The owner, which is Leo, has read-write. The group owner, which is Leo as well, that second column here, has read-write, and everybody else has read. So everybody on this entire system can actually read this file. This is a directory, and owner read write X, so I can read and write into the directory as well as go into the directory. That's what that X is telling you. Group, which is also Leo, can do the same thing, and users on this system can also do it. Read and execute. They can't write anything to it, they can't change anything in it, but they can go into it and look. So each of those things, they're called octal modes. Don't worry about that. What the deal is, though, is that each of those permissions has a number value associated to it. Read, write, execute. So if you want them to have any of these or all of these, all you have to do is add together the numbers that represent the permission that you want. So if you wanted read, write, and execute, you would just do 4 plus 2 plus 1. And that is 7. Let me show you how this is applied. So I've got this new file thing with read, write, read on it. So this, if you wanted read, write, that would be 4 plus 2 is 6. Read, write, 4 plus 2 is 6. And read, 4. So this particular file has an octal mode of 664. Let's say I wanted this file to have 777. And that'll give you 4 plus 2 plus 1 is 7. So that'll give me RWX, RWX, RWX. And that would basically make this file executable to anyone on the entire system. Anybody can look at it, modify it, and run it. That's what read, write, X means. Look at it, modify it, run it. So if I wanted to make some changes to that, I'll do change mode 777 new file. I know that looks weird. This is because there's a space in the file, and Linux doesn't like spaces, so you have to start a space with that. And now let's look at it again. Yeah, now it's green. It's special, so it's telling you, hey, be careful. This file is executable. And take a look. So I've got some very common modes here. So if you just want read, write all the way across, RW, 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 that's 666. RWX, RWXR, 774. RW, RW, nothing, 660. So if you want nothing, 0. RWR, 640. And you can just play with it, right? You can have 5, you can have 4, you can have 3, 2, 1, all kinds of fun stuff, right? Only start, if you're going to play with these permissions, really only play with permissions of files that you have created inside your home directory. You can really break an entire Linux system by changing the permissions on files that you don't know what they do. So really just concentrate on stuff that you've created. But you can do that with change mode. Now, if you're not a fan of addition, you can do this a different way. You know what? I don't even know. Yeah, I don't want to dive into that. It's just going to be more than you're going to need to know. So yeah, just do the math. Simple, quick math. In the Linux class, we'll go into another easier way to deal with this. But octal modes work everywhere, so you just best be aware that it exists. This is the only chart you'll need to figure out what you want. And you just have to remember that user owner, group owner, everybody else. All right. Right, chmod. Here's an example of how to do that on a directory named chmod or named Minecraft Backup 2-4. I have that right here. Right. So you can see what it looks like. That line there. And then changing ownership. Right? Like, if you wanted to change the ownership of the group of this file. So new file, right? You can do, well, let's change the user owner first. So root, new file. Let's do sudo change owner to root for new file. Now, root owns my file. Now, I'm in the Leo group, obviously, so I can still read, write, and execute this file. And even if I weren't in any groups, I'd still be able to read, write, and execute this file. But if we chmod 770, Ooh. Because root owns it, I can't do it. So let's do that again as root. There you go. Now, everybody else on the system cannot do anything to it. So root owns it. Leo group owns it. Everybody else gets nothing. So we can also change the group ownership. Let's say to the ADM group, new file. Right? Root owns it. ADM group owns it, or admin group owns it. And Leo now gets nothing. Leo's permissions are pretty much denied all the way up and down. Oops. Now, the other idea with this is that you don't have to use the chgroup command. Remembering one command is a little easier, I think. So chown, like we used before. You can set both the user owner and group owner at the same time. So let's do Leo : Leo, new file. So left of the colon, oops. Left of the colon is the user owner. Right of the colon is group owner. Hit enter. Oop. Let me type it right. And everything's set back to normal. Leo. Now, the idea of inheritance does not exist typically in Linux because it's actually kind of a bad idea to be dealing with stuff like that, especially if you have directories and directories. But if you want to force it, let's say you want to change everything from this directory all the way down inside of it, you want Rob to own it. You do the same thing that we did to change ownership on a directory, but you add this option. It stands for recursive. This is the same idea as inheritance. Everything here and below will have this change. So if you're changing the ownership to Rob, using this option, then everything inside will also be owned by Rob. So let me go in here. Let's do touch file 1, touch file 2. All right. So I'm going to change the group ownership. Okay, let me go back in real quick so I can show you. Everything is file 1, file 2, user owned, group owned by Leo. Let me back out real quick. And we'll do a chown. And you can just do with, if you just want to do group ownership changes, you can still do that only with change ownership, chown. Well, actually, I own it. So chown, ADM, oh wait, let's do -R, ADM, untitled folder. Oh, okay, I know what I did. ADM is not a user, it's a group. So if you do a colon, right? No, okay. So before I did Leo : Leo, that changed the user and the group. If you just want to change the group, you leave the colon, but don't put a user owner on there. Now let's look. ADM owns that directory now, or group owns that directory. And inside of it, ADM also group owns these files. So that's what recursive does. This and everything inside of it. A lot of different commands will have this recursive option. Pretty much any kind of file operation command will have a recursive option, just in case you want to do this to everything and everything inside of it. All right. Now the last little bit, let me add a disk and I'll show you real quick how to deal with this. Oh, I did it again. Stop clicking that, man. All right, come in here. Let's add ourselves a secondary disk on the SATA. Create. Cool. 5 is what I did over there. Let's do the same thing. Cool. And cool. All right, so let's start that bad boy up. Let me check. I want to make sure I'm giving you guys a good example for the lab. Okay, yeah, so I'm using disks. So we're not going to do manual disk mounting, though I will show you. Yeah, I'll go ahead and show you because it doesn't take but a sec anyway. A few things you got to know, but overall, we're good. All right, so we got that new disk in. You'll want to go to disks. Uh-oh. No, go back. There we go. You'll want to go to this disks application. This is pretty much like disk management in Windows. You'll see your secondary disk that you just created. You'll want to format. This is pretty much like the initialization and creating a volume. You can leave it as ext4. This is pretty much the default for most Linuxes, except you'll see XFS every now and then. And what did I call the other one? We called that one extra. We'll call this one extra as well. Yep. It's going to create a new partition table. It's going to make the whole thing. It's going to create it as dev SDB. It's going to want root privileges. Oops. If I could type my password right. There we go. But it doesn't automatically mount it, nor does it ask you for a drive letter, right? Because Linux doesn't do drive letters. If you hit this play button, it'll mount it. And if you look at where it's mounted, in media, as I mentioned before. Now inside of here, we're going to check on these permissions, make sure everything is on the up and up. Yep, looks good. If we, here, let's do open terminal here. Let's do LSL. Yeah. So Leo owns the whole drive inside of extra. There's that lost and found folder. Every partition has one. And there is the untitled folder that we had that we were talking about before, and Leo owns that. So that means that I can go into untitled folder and touch file 1, and then there'll be a file 1. So I know I'm doing that pretty quick, but all I did was create a file inside of here called file 1, and there it is. If I add some text to it, no. Save that bad boy. You can come to the terminal, cat, and you can see that stuff that I typed. Right? It's always nice to have a visual for all of these crazy command line things that I'm doing. And that's it. One of the big things that I want you to do in this lab, though, is unmount this guy. And you go into the mount options here. Turn off defaults. And you want to go in and actually change where it's mounted. So in the lab, let me see, I'm asking you to, all right. So I want you to put a 10 GB directory in your home folder. And this is really more just an exercise of figuring out how file pathing works and all that stuff. So your home folder, if you just click on the folder down here, it takes you straight to your home folder. Create yourself a 10 GB. There it is, right? Let me see. One cool thing that you can do, because I'm asking you to do this, right? There's no browse here. That would be kind of nice, but there is no browse. What you can do is right-click on 10 GB, open in terminal. Notice it tells you that's where you are. Type pwd. And there you go. Look at this. You can copy this, paste it in here, and hit OK. Yes, yes. Oop. Still can't type my password. And then play. Now if we look into 10 GB, ooh, look, my folder is there now. That file that I had before is still there. This is how you do it. This is the equivalent of assigning a drive letter and getting to it. It just is wherever you told it to be. Now, anytime you click on extra, it still takes you there, right? But notice, Leo 10GB. Oh yeah, I forgot about that. You can also do this, right? If you go into 10GB, hit this little pencil, and you can copy the file path out from there as well to paste in if you want. And notice, mounted at home Leo 10GB. So in your screenshot for the lab, I'm expecting to see home, your name, 10GB. All right, well, we're out of time, so I'm not going to show you the manual mounting stuff. Plus, that's probably just enough to make your head explode anyway. So we'll stop here because that's pretty much my time. So anyhow, if you have any questions, please let me know. Just send me a message on Slack, whatever, and we'll get it figured out. If we have to, we can do like a WebEx session or something like that for me to be able to like show you in real time. Or I don't know if I can take control of your computer that way, but we can figure something out overall. So just let me know if you have any questions or troubles or anything like that, and we can get it situated for you.